Hello everyone. Today we're going to be talking about a new topic called polynomials. But before we get started today, we actually have a special joke from Shivami. Her joke is, why are obtuse angles so sad? Because they're never right. And with that, we will get started. So we're going to talk about polynomials today. This is actually the first section of chapter 8. And if you want to try to take notes on your own, or if you want a little reference, you can go to page 465, and we're going to go all the way up to 467 on our notes. And I'll do a lot of the examples that they have there, so that way you have something to reference as if you want to read along as we're going. So, 465, polynomials. Now, polynomials are really important. This whole chapter is really important because it's really going to set up a lot of the building blocks for the higher levels of math you'll get into. So, a lot of what we do now is going to be really brand new to us, but it's setting up the building blocks for the future. So, we'll start off with a polynomial, and we define a polynomial as a monomial, or the sum of monomials in simplest form. And in a polynomial, each monomial is going to be a term of the polynomial. So let's just say we have x squared plus 4x plus 1. So each monomial, this is a monomial, this is a monomial, this is a monomial. Each monomial is a term of the polynomial. Now, when it comes to polynomials, there's special names for different types. So one way that you can name a polynomial is by the number of terms involved. So if you have one term, we refer to that as a monomial. If you have two terms, here we have two terms, and they're not like terms, so after you simplify everything or combine like terms, we can't combine, we would call this a binomial. And if you had three terms, let's say we had a plus 2, then we'd call it a trinomial. And after a trinomial, we would just say it's a polynomial with 4 terms, a polynomial with 5 terms, and so on. So that's one way that we can kind of classify polynomials. Another way that we're going to classify them is by the highest degree. Now, in order to find the highest degree of a polynomial, you're looking to the exponents, the highest exponent you're raised to. So here it would be of degree 2. And degree 2 has a special name that's called a quadratic. So this would be an example of a quadratic. We'd call this a quadratic trinomial. If we had something like this, maybe 2x minus 5, this is degree 1, your highest degree is to the first power. This is a linear, which we've dealt with linears a lot this year. So this would be a binomial that's linear. And there's plenty of others that we can go through. On page 465, there's actually a really nice table that has different degrees and the special names for them. Like degree 0 is called a constant. That would be like this. There's a constant. You have x to the 0th power. That's why you don't see the x there. And then you have like degree 3 would be a cubic, and there's so on and so forth. There's plenty of names there. So we're going to start off by simply just, given different polynomials, can we classify them by the number of terms and by degree? So let's go ahead and let's just say we have 3x to the 4th plus 2x minus 5. So with this polynomial, since there's 3 terms, we would say it is a trinomial, and its degree, well, it's a 4th degree, so its degree is 4. Highest power is 4. If we have, let's say, something that looks like 5x plus 2x squared plus 7 minus 13x to the 5th. Well, this polynomial, it would be a 4-term polynomial, because you can't combine any like terms. So there's 4 terms in this polynomial, or 4-term polynomial. And its highest degree, while you're looking, would be 5. So it's a 5th degree polynomial. You're looking for the highest degree in one of the terms. So this term has the highest degree, it's to the 5th. We'll do one more and then we'll move on to standard form of a polynomial. So let's say we have 2x plus 3x squared minus x plus 1. So here it looks like we have 4 terms, but notice we can simplify. So your 3x squared has no like terms, but 2x minus x is simply plus x plus 1. So in simplest form, after all like terms are combined, we will see that we have 3 terms. So again, we have a trinomial. And our highest degree is 2. So that would mean it's a quadratic. So it's a quadratic trinomial. And you can do a little practice with these identifying. I'll give you some problems from the book. You're just looking for the number of terms after you simplify, and then the highest degree that you have. So on to standard form of a polynomial. In standard form, I'm going to use the one right out of the book here. We're going to be written like this. Let's say this is our polynomial. And we'll explain why this is in standard form. Plus 7. So this right here is in standard form of a polynomial. Standard form. And this is in standard form. When you're listing in standard form, you list all of your terms in the order of their degree. So the highest degree goes first, then the next highest degree, then the next, and so on. So 3rd degree, 2nd degree, 1st degree, 0th degree. So that's how you're going to list in standard form. It's really nice to stay organized like this, especially when it comes to adding and subtracting polynomials that we'll talk about in a minute. And when you're in standard form, another thing you want to point out is your leading coefficient. So this is our leading coefficient, and it would be 4 here. So just like the problem you see in the book, this we have a leading coefficient of 4. Our highest degree, you can look, is 3. Highest degree is always going to be to the left. So you can tell your degree of the polynomial when you're in standard form, because everything is nice and organized in order for you. So we'll just take a couple, just convert them into standard form, and then we'll try some adding and subtracting. So let's say we have, I'll go right from the book here, 3x squared plus 4x to the 5th minus 7x. Let's say we want to write this in standard form, and then we'll identify the leading coefficient. So in standard form, you're looking for the highest degree, and I see it right here in this middle term, and that's going to become your first term. So your first term is 4x to the 5th. Then, so we've already taken care of that. Our next highest term is our 3x squared, and that is a positive 3x squared, so we're taking care of that. And our last term is minus 7x. So here we are in standard form. Our degree is in decreasing order. Our highest degree is first, and our leading coefficient is right here. Our leading coefficient would be 4. Leading coefficient is 4. And if you want to try, if you're looking in the book, problem right next to it, we'll do that one as well. You can try on your own and then double check and see if we have the same answer. We have 5y minus 9 minus 2y to the 4th minus 6y cubed. We want to write this in standard form, and we want to identify the leading coefficient. So if we go in standard form, look for the highest degree of each term. Highest degree is right here. Bring the negative with you. Negative 2y to the 4th, taking care of that. Our next highest degree is the minus 6y to the 3rd. And then we have positive 5y minus 9. We're in standard form. Our leading coefficient is right here. Leading coefficient is negative 2. And again, being in standard form is really useful when it comes to starting to do operations with our polynomials. So on to our next topic with polynomials. And today we're going to really focus on just how to add and subtract polynomials. I'll do one example of each. I'm going to show you a couple of different methods, the horizontal method versus the vertical method, and I'll explain, give you little tips on how to stay organized. So first, let's go ahead and we'll add some polynomials. When you're adding polynomials, you're essentially just adding like terms together, and there's going to be two different methods that we can do. We'll do the same problem twice with both different methods. We just want to make sure our final answer, our final expression, is going to be in standard form of the polynomial. So the first one we have 2x squared plus 5x minus 7. There's a trinomial for us. And we're going to add that with the trinomial 3 minus 4x squared plus 6x. All right, so first let's do this with the horizontal method. Horizontal method, essentially what you're going to do is you're just going to simplify everything horizontally. And here's how I like to do it. We have, not 4, 2x squared plus 5x minus 7. And we're just adding this. So it's kind of like you're distributing a positive 1, so these parentheses can go away. And we're going to have 3 minus 4x squared plus 6x. You could rewrite this in standard form if you want to. I'll just look for our like terms and kind of mark them off as we go. So our highest degree is to the second power. So I have 2x squared, and I'm subtracting 4x squared. So we should end up with negative 2x squared. Now as you go with this, I like to underline as I go. I've taken care of these, so I don't need to worry about them anymore. They're accounted for, they're combined down here. If you don't do anything to mark off, you might have like 10 terms and you're going to forget one, and that just ruins the whole problem. So make sure you're staying organized. So I'm going to go ahead and take my 5x, and I'm going to add that with, we have an x over here. We have 6 of them, so 5x plus 6x, we're going to have 11x. And now we're left with negative 7, and we're adding 3 to that, so we'll have minus 4. And right here we're in standard form. So there we go, in standard form. This is the horizontal method, and really the tip I have for you is underline, or some people like to put a little check, or maybe like a little, cross them out as you go, to make sure you're not forgetting anything, or not counting something twice. So there we go, in standard form. Another method some people use is the vertical method. So for the vertical method, we're going to take 2x squared plus 5x minus 7. And you're going to be adding. Now I would rewrite this in standard form. Negative 4x squared plus 6x plus 3. To add, you're going to set them up vertically. So we're going to set it up as 2x squared plus 5x minus 7. And we're adding negative 4x squared plus 6x plus 3. You want to set up all of your like terms, because then you can just simply add straight down. So negative 7 plus 3, negative 4. 5x plus 6x, 11x. It's a positive 11x. 2x squared plus negative 4x squared is minus 2x squared. And same answer in standard form. And we're all done. Some hints with this. Make sure you have them both in standard form so you can line up your like terms very easily. If, let's say, a little sidebar here, let's say we didn't have this 6x, then when you wrote them out, 2x squared plus 5x minus 7, negative 4x squared, I would just put a plus 0 or just leave a space there. Even a space is nice, so you know that there's none of those terms. If we didn't have that 6x, that's what this little scenario would be over here. Just leave a space there so you don't accidentally like drag something over. The whole point of the vertical method is lining everything up. So that's how you can add some polynomials, really just combining like terms. Let's talk about how we can subtract, and then we'll be all done. So here's another example. We'll go right from the book. We have 3 minus 2x plus 2x squared minus the polynomial 4x minus 5 plus 3x squared. And now we're subtracting two polynomials here. I'll rewrite them both in standard form, just so we can see our like terms a little easier. We're subtracting 3x squared plus 4x minus 5. And there's a couple ways to think about this, but really what you're going to end up doing is just distributing this negative sign. So you could think of it like you're adding the opposite. So instead of saying like minus 2, you're saying plus negative 2. And how that works is, well, this is our original polynomial. And from this polynomial, we're subtracting, but I'm going to say we're adding the opposite. So we're going to go ahead and distribute the negative. You're adding negative 3x squared minus 4x plus 5. So you're adding this. And if we want to use the horizontal method, we can just say, maybe we can take these parentheses away, and we look like this. A minus sign here. Take your x squared, your highest degree. You have 2x squared minus 3x squared. That gets you a negative x squared. Taking care of those. You have negative 2x minus 4x. That gets you a negative 6x. Taking care of our x's. And you have 3 plus 5. Well, we should get 8 there. And this would be in standard form. So all comes down to if you prefer the vertical or the horizontal method. Just make sure you're keeping track of whatever it is that you are simplifying. In the future, I think the horizontal method is going to be better for us because we might end up multiplying, or we might have something called foiling. So it's just really about keeping track of your like terms here. Alright, that's all we have for the day. I'll send you guys some problems to try to make sure you feel comfortable with this. As always, if you have questions, please email me or send comments on Classroom. That way we can work out whatever it is we're having trouble with. Alright guys, have a nice day.